This is 10-4, factoring to solve quadratic equations, and we skipped 10-3, which was solving quadratic equations. So I just want to give you a quick overview of what happened in 10-3 since we're not going to do it. Let's see, a quadratic function you learned in 10-1 is y equals ax squared plus bx plus c. And thus a quadratic equation is ax squared plus bx plus c equals 0. So just a little bit different. Quadratic, so they have that x squared term. Quadratic function is y equals so that you can graph it. A quadratic equation is set equal to 0. So here are the solutions of a quadratic equation, which is what we're talking about today. We're going to solve quadratic equations. So we want to find the solutions of a quadratic equation. Well, what are the solutions of a quadratic equation? The solutions are their x-intercepts. So here are the solutions to this quadratic function of y equals x squared minus 4. Here is the solution for the quadratic function y equals x squared, and for this quadratic function y equals x squared plus 4, there is no solution, because remember the solution is the x-intercept. Well, it never crosses the x-axis, therefore this one has no solution. And on the first one, the solutions are -2 and +2. So if they ask you to find the solutions of the quadratic function y equals x squared minus 4, that'd be your answer, -2, +2. But there's a way to find that. To find the solutions of a quadratic function, you just have to solve its related quadratic equation. So if this is our quadratic function, then its related quadratic equation is x squared minus 4 equals 0. So we just need to solve for x. So what would you do first? Well, add 4 to both sides to get rid of that. So you end up with x squared equals 4. And then how do you get x alone? Well, the opposite of squaring something is to square root it. So just take the square root of both sides. So x equals plus or minus 2. And the reason it's plus or minus is because the square root of 4 is 2, but it could be +2 or -2, because 2 times 2 squared is 4, and -2 squared is also 4. That's how you get the two solutions of -2 and 2. Let's look at this equation over here. So it's your parent function, y equals x squared. Its related equation is x squared equals 0. And so if you want to find the solutions, you simply solve its related equation, which is x squared equals 0. So how do you solve that? X squared equals 0. Well, we got to get x alone. Square root both sides. So x equals, what's the square root of 0? Well, it's just 0. And yeah, you could put plus or minus, but there's not a +0 or a -0. There's just 0. And so we see on its related graph, yeah, its x-intercept is 0. That's where it crosses that x-axis, or in this case, just touches it. And then here we have x squared plus 4 equals 0. And in fact, I'll just use that original equation. So how would we solve this? Well, subtract 4 from both sides first. X squared equals -4. The opposite of squaring is square rooting, so square root both sides. And x equals, can you take the square root of a negative number? We'll go ahead and try. If you put this in your calculator, you will get an error because there is no number times itself that will give you a negative. Like here, the square root of 4 is 2 or -2 because 2 times 2 is 4. -2 times -2 is 4. So the square root of 4 is 2 or -2. For the square root of -4, there's no number times itself that will give you a negative, and that's why you get no solution. And you see, yeah, it doesn't cross the x-axis. So today, when we're factoring to solve quadratic equations, we're trying to find the solutions. That you're solving the related quadratic equations to find the solutions. And again, the solutions just are, where would it cross your x-axis? So we have a property that we're going to look at in 10-4, but before I do that, I just want to go through a little review of how you graph. So I started with this quadratic function, y equals x squared minus 2x minus 3. And to graph it, you know, our first step is to find the axis of symmetry and the vertex. So the axis of symmetry, you remember the equation for that is x equals -b divided by 2a. So I just plugged in, this is, remember, your a and your b and then your c. So my a, or my b is -2. The opposite of b is +2. divided by 2 times a, which is just that imaginary 1, simplifies that to be 2 divided by 2, which is 1. Therefore, my axis of symmetry is x equals 1. So I'm going to go to x equals 1, and I'm going to draw my axis of symmetry. And you shouldn't have those arrows on the end. Let's take care of that. Let me change that into a different line and straighten it up. So there's my axis of symmetry, x equals 1. Then you use that. You know your vertex has to be on this axis of symmetry because that's right down the middle of your parabola, and your vertex is right in the middle of your parabola. So to find your vertex, take your x value of your vertex, which is 1, plug it into your equation to find y. So I plugged in 1 squared minus 2 times 1 minus 3. 1 squared is 1. Negative 2 times 1, negative 2 minus 3. And then 1 minus 2 minus 3 is negative 4. So your vertex is 1, negative 4. So plot your vertex over 1, down 1, 2, 3, 4. There's your vertex, 1, negative 4. Then we have to find 2 other points. We always use one of our points is the y-intercept. So just plug in 0 for x. 0 squared minus 2 times 0 minus 3. 0 minus 0 minus 3 is negative 3. So your y-intercept is 0, negative 3. Over 0, down 1, 2, 3. There's our y-intercept. And then one other point, remember your other point just needs to be on the same side of your axis of symmetry as your y-intercept was. So I just chose negative 1. You could have chosen negative 2, 3, 4, any of those. But I like to choose the smallest one, so I chose negative 1. And I plugged in negative 1. Negative 1 squared minus 2 times negative 1 minus 3. Remember, every time you substitute, it always goes in parentheses. Negative 1 squared is 1. Negative 2 times negative 1 is 2. Minus 3. So 1 plus 2 is 3. Minus 3 is 0. So your other point is negative 1, 0. So negative 1, 0. And then finally, you know that you reflect. So I'm going to reflect over my axis of symmetry. So this one's 2 away, so my other point's 2 away. This one's 1 away from my axis of symmetry, so my point on this side will just be 1 away. And then finally, you just draw your parabola. And you know I always have trouble with this. Oh, goodness, that was worse. Okay, last time I'm going to try. That's good enough. Oh, gosh. Okay. And you know it's supposed to look like a U, whether or not mine does. So there's your parabola. So in this case, what would be your solution? What's your solution? If they asked you to solve this quadratic function, they want the solutions. Remember, the solutions simply are your x-intercepts. So what are my x-intercepts? Well, negative 1 and positive 1, 2, 3. So what's my solution? Negative 1, positive 3. But there's another way to find these solutions without having to go through this whole thing and graph your parabola, because there's several steps. This takes some time. So I don't know about you, but I want a quicker way, and there is a quicker way. The quicker way is to first factor it. So take your x squared minus 2x minus 3 equals 0 in this case. Remember, this is the related quadratic equation, and we're going to factor it. And so you know that you can just do the factors of the last term that add to be the middle term, and that's because you don't have a coefficient for your x squared term, so you can just do this 2-column method. So we need two numbers that multiply to be negative 3, but add to be negative 2. And if we're going to multiply to get a negative, we need to do a positive times a negative, and that'll give us our negative. And since we want a negative over here, we'll make our bigger number negative. So how about negative 3 and positive 1? Negative 3 times 1, negative 3. Negative 3 plus 1 is negative 2. That works. So let's go ahead and write our binomial. And it's also set to 0, and our variable is just x, so x and x, minus 3 plus 1. Then you simply say, okay, well, if I'm going to take a number, and these are really, they're two different expressions, and when I multiply these two expressions together, I'm going to get 0. That means one of these expressions actually has to equal 0, because that's the only way you can multiply to get zeros, if you do 0 times some other number. So one of these has to be 0. So I'm going to say x minus 3 equals 0, or x plus 1 equals 0. One of these has to be 0, and then solve. So x minus 3, so add 3 to both sides. X equals 3. Subtract 1 from both sides. X equals negative 1. And what were our solutions when we graphed? Negative 1 and 3. And what do we get here? Negative 1 and 3. So you see, this method is much quicker excuse me, this method is much quicker to finding your solutions of your quadratic function than having to go through all these steps to graphing. So that's what we're going to be doing today, finding the solutions of quadratic functions or quadratic equations by graphing. And what we just did is exactly what the zero product property says. If a times b is 0, then one of them has to be 0. So you set both of them equal to 0. So it's the same thing as what we just did. We said, okay, x plus 1 times x minus 3 equals 0. Then one of these has to equal 0, and you just solve both, and that gives you your solutions. X plus 3, or x is positive 3, and x is negative 1. All right, in the next couple of videos, we will get on to our example.